Question number 6. The particle model can be used to explain the properties of gases. 6.1 is an AO1 question. Describe the direction of motion of the particles in a gas. This question is from the topic of particles motion in the gases. We know that the gas particles are moving in different directions. So the student can write the particles are moving in random directions or in all directions. And the student will be able to get 1 mark for this answer. 6.2 is an AO1 question. Explain why heating a gas increases the average speed of gas particles. This question is related to the temperature of the gas and the kinetic energy of the particles. Heating increases the temperature of the gas. By increasing the kinetic energy and the potential energy, we want to say the internal energy of the gas particles increases. So it means the temperature of the gas is directly proportional to kinetic energy of the particles. As the temperature increases, the kinetic energy of the particle increases. It means the speed of the particles increases. We know the formula, the kinetic energy is equal to half mv square. As the temperature will increase, the speed of the particles will increase. 6.3 is an year 1 question. Water can exist as either a liquid or gas at 100 degree. Explain why a mass of gaseous water at 100 degrees Celsius contains more energy than an equal mass of liquid water at 100 degrees Celsius. This question is from the temperature changes in a system and internal energy. We can see from here a water molecule is present, another water molecule is given here. A weak intermolecular force is present between the neighboring molecules. This force is very weak as compared to the bond present between the molecules. When we give the energy, we are able to break the intermolecular forces present between the molecules, and the water from the liquid states changes into the gaseous state. We know that the molecules in the gaseous form, they are more energetic and they are free to move because there is less force of attraction present between the molecules. So the model answer is there is a force of attraction present between the molecules in the liquid state, as it is mentioned here. Therefore, energy is required to break these forces to change the water from liquid state to gaseous state. When we are able to break these forces, these molecules will get free into the gaseous state. The extra information is given for the student. In gaseous state, the force of attraction is very weak between the particles because of having high internal energy. In gaseous form, they have more energy and they are free to move. Water vapor is a gas. Gases changes the state when they cool. Figure number 8 shows condensation on a cold bathroom mirror, which is shown here. 6.4 is an AO2 question, and this question is from the topic of density and specific latent heat. A volume of 2.5 times 10 raised power minus 5 meter cube of condensation form on the mirror. The density of the water is given 1000 kilogram per meter cube. Specific latent heat of vaporization of the water is also given 2.26 10 raised power 6 joules per kilogram. Calculate the energy released when the condensation forms on the mirror. We are already given the density, the volume, and specific latent heat. We need to find the energy released. We know that the values are given here, specific latent heat of vaporization. We want to calculate the energy release when the condensation happens on the mirror. We know that energy release is equal to mass of the substance into specific latent heat of vaporization. The mass is unknown, but the density and the volume are given here. We will use the concept of density to find the mass of the substance. Then we will use the formula E is equal to mass into specific latent heat. Let's see the model answer. First, calculate the mass. Density is equal to mass per unit volume. The density of the water is given, that is 1000 kilogram per meter cube. Mass is unknown and the volume is already given here. We're going to use the value here. We need to rearrange. We go on the other side, we'll find the mass of the water. The mass of the water is 2.5 10 raised power minus 2 kilogram. Now we will use the formula energy is equal to mass into specific latent heat. The mass is already calculated. We'll use here. And the value of specific latent heat is 2.26 10 raised power 6 joules per kilogram. We're going to use this value here. By using the calculator, we will get the answer 56,500 joules of energy is released when the condensation happens on the mirror. 6.5 is an AO3 question. The student need to give the reasons and it is an argument in the favor or against. The central heating boilers burns gas and use energy released to heat the water. Modern condensing central heating boilers take advantage of the energy that is released when the water condenses. Waste water vapors produced when the water is heated in the boiler is used to preheat the cold water entering the boiler. Give some of the arguments in favor of condensing boilers compared to the old non-condensing boilers. This question is actually an AO3 question, and this question is from the topic of efficiency and energy changes in a system. In our model answer, we can see that the waste water vapors have more internal energy than the cold water because they are already in vapor form and they have more kinetic energy and potential energy. When wastewater vapors condenses in the modern condensing boiler, energy is released as the result of condensation. That energy is used to heat the cold water. Therefore, the boiler needs less energy by burning the gas to heat the water, and it is cheaper to run. Therefore, less waste gases such as carbon dioxide is produced in the atmosphere as the result of using the energy produced by the condensation process in the boiler.